In this video, we're going to be talking about how to graph lines in the coordinate plane, and we're going to cover everything about this process, including point-slope form for the equation of a line, slope-intercept form for the equation of a line, and standard form for the equation of a line. Knowing how to graph lines is a super important and foundational topic from algebra. So before we talk about how to graph lines, let's quickly remind ourselves how to graph coordinate points. Let's say, for example, we have two coordinate points, 1, 1, and how about 3, 2? Okay, so when we have these coordinate points, remember that the first number is x and the second number is y. So if I want to graph the point 1, 1, I always start right at the origin in the middle, and I move out along the x-axis 1 unit, and that takes care of the x value, x equals 1. And then to get y equals 1, I move up 1 unit. So I moved out 1 unit in the positive direction of the x-axis, then I move up 1 unit in the positive direction of the y-axis, and I plot my point right here at 1, 1. Now if I want to do positive 3, positive 2, I move out in the positive direction of the x-axis 3 units, and then in the positive direction of the y-axis 2 units, and I get to the point 3, 2. So we know how to plot those coordinate points, but what happens when I take these points and I draw a line through them that looks like this? How would I go about finding the equation of that line? We're going to be talking all about how to find the equation of this line and how to write it in different forms, or given the equation of a line, how to go about graphing it like this. So we're going to look at it from both directions. Now, before we go forward, we need to talk about the fact that there are really only two pieces of interesting information about any line. It doesn't matter what kind of line it is or what it looks like. If it's a line, there's really only two things that we care about. And those are, number one, points on the line, and number two, the slope of the line. So we already talked about points on the line. We know that this point here is the point 1, 1, and we know that this point here is the point 3, 2, and those both lie on the line. So we already have an idea of points on the line. But what about the slope of the line? Well, this part's really important too. So the slope of the line you can think of as how fast the line is moving up or moving down. And really, when it comes down to it, slope is just defined as how fast y is changing compared to how fast x is changing. So what does that mean? Well, here's an example. So it means if I start at the point 1, 1, I can move 2 units here to the right. And then from there, I can move 1 unit up. And what happens is that I started at the point 1, 1, and I arrived at the point 3, 2. So I started at a point on the line, and I ended at a point on the line. And to get there, I moved over to the right 2 units, and I moved directly up 1 unit. And that's all we need to know to define the slope of this line. So the slope formula we always use, we call the slope m. So the slope is m. We always want to remember slope as rise over run. In other words, how much am I rising up or down compared to how much I'm running left or right. So in this case, I rose up 1 unit. I went in the positive direction 1 unit. So my rise was positive 1. And my run, I went 2 units in the positive direction of the x-axis. So the run would be positive 2. Therefore, the slope m is equal to 1/2. And remember too that we can go either way. So for example, we could have gone here, rise 1 unit over run 2 units, and we would have gotten the same value, 1/2. Or alternatively, we could have started at the point 3, 2 and moved over to the point 1, 1. So we could have gone down 1 unit, and our rise would have been -1, and then we could have gone over 2 units here, and we would have moved 2 units to the left, or in the negative direction of the x-axis 2 units, and so our run would have been -2, and we would say -2. But notice here that when I have -1 over -2, those negative signs cancel, and I still end up with a positive 1/2. So no matter which way you look at the slope, if you move from one point to the other, or vice versa, and if you do your run first, then your rise, or your rise first, then your run, no matter which way you look at it, you should always end up with the same slope m. So how do I find the equation of a line? Well, remember before, we said that there were 2 important pieces of information: points on the line and the slope of the line. Well, if I want to find the equation of a line, I'm again going to need 2 pieces of information. But it could be some combination of those points and slope. So for example, I could have a point and another point. In other words, if I just have 2 points on the line, then I can find its equation. I can also find its equation if I have a point and the slope. One of the tricky things about graphing lines is that these are the only combinations of information that will allow me to find the equation of a line. And at first glance, that seems simple. It's obvious that, okay, I just need a point and a point, or I need to know one point and the slope of the line. The problem is that a lot of times you're given various pieces of information that don't necessarily look like a point or a slope. They're kind of disguised. For example, you may be given a point and the y-intercept of the line. And at first glance, you think to yourself, this combination of information doesn't match either of these, so I won't be able to find the equation of the line. When in fact, the y-intercept is a point on the line, because the y-intercept is the point at which the graph crosses the y-axis. So for example, if you were told that the y-intercept was y equals 2, then you could go over to your graph here and say the graph crosses the y-axis, so it crosses this line here at y equals 2, which is right here. Well, what we need to realize is that this is also the point 0, 2. Whenever we're crossing the y-axis, the value of x is 0. So a y-intercept will always have an x value of 0, and then whatever you've been told is the y-intercept. So when you're given a point and a y-intercept, as an example, the y-intercept is actually a point, so what you're really given is a point, and you've satisfied here this first situation where you have a point, and you can actually find the equation of a line. And we'll talk more later in the video about all the different ways that points and slopes can be disguised in line graphing problems. But before we talk more about these special cases, let's go ahead and talk about the 3 different forms that the equation of a line can take: point-slope form, slope-intercept form, and standard form. Let's go ahead and start with point-slope form. In this form, the equation of a line is given by y minus y sub 1 is equal to m times x minus x sub 1. Now, what does all of that mean? Well, let's go back to a line that maybe passes through this point here and this point here. Now, with point-slope form, we need 2 specific things. And to remember what they are, we just have to remember the name of the form, which is point-slope form, and tells us that we need one point and the slope of the line in order to put the line in this form. So we need one point on the line. Let's go ahead and use this point here, the point 1, 2. And then we need the slope of the line. Well, in order to find the slope of the line, we actually need 2 points along the line. So we have this other point here, the point 3, 1. To find the slope, which remember is m, we always use the formula m is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. That just means that one of our coordinate points, either 1, 2, or 3, 1, will give us the coordinate point x sub 2, y sub 2, and the other coordinate point will be x sub 1, y sub 1. It doesn't matter which point you use, as long as you keep this consistent and you always lead with coordinates from the same point and then subtract coordinates from the other point. So let's go ahead and say here that this is x sub 2, y sub 2, and that this is x sub 1, y sub 1. Now, if that's the case, to get m, we just take y sub 2, which is 1, and we subtract y sub 1, which is 2. And then we divide that by x sub 2, which is 3, minus x sub 1, which is 1. And we see here that we get 1 minus 2 is negative 1, 3 minus 1 is 2, so negative 1 over positive 2 is a negative 1/2. That means that our slope m is equal to negative 1/2, so we now have the value that we need for m. And then for x sub 1, y sub 1, we can use either point along the line, either 1, 2, or 3, 1. Again, it doesn't matter which one we use, let's go ahead and use 3, 1. So we plug into the point slope form for the equation of the line. We always leave y and x alone, so we'll leave y as is always, and then we subtract y sub 1, and we said we were going to use the point 3, 1. The y value in that point is 1, and that'll be equal to m is the slope, negative 1/2, so we plug in negative 1/2, multiplied by x minus, and then x sub 1, we take the x value from the same coordinate point. So we have to take the x value from this coordinate point, so that is 3. This then is an equation that represents this line, so if we were to start with this equation and graph the line, we would find that this is the line that we come up with. This is point slope form for the equation of the line. Now what about slope-intercept form for the equation of the line? The formula here is going to be y equals mx plus b. As always, m is our slope, and b will be the y-intercept. Remember, the y-intercept is the point at which our graph crosses the y-axis. In this particular line here, this point right here is where the line crosses the y-axis, so whatever point that is would be the y-intercept. Now, when we're talking about slope-intercept form, we can get at this form a couple of different ways. And that's because we have really 3 things going on in our slope-intercept formula. The first thing is the slope, m. The second thing is the y-intercept, b. And the third thing is a coordinate point, where the coordinate point is given by the x right here and the y right here. So if we have any 2 of those 3 pieces of information, we can find the equation of the line in slope-intercept form. Let's go ahead and say here that we have a point and the y-intercept. So we can see here that the y-intercept is the point 0, 2. For the y-intercept, the x value will always be 0 because, of course, we're right here along the y-axis where x is always 0. So x will be 0, and then we cross the y-axis at y equals 2. So the intercept point is at 0, 2. That means the y-intercept is going to be here, b equals 2. And then we can use a point, let's say this point down here at negative 2, negative 1, to be the point xy. So when we plug into our slope-intercept formula, we take the coordinate point negative 2, negative 1. The y value there is negative 1, so we get negative 1 is equal to, we don't know m, the slope yet, so we'll leave that in, but we know that x is negative 2. And we know that the y-intercept, b, is 2. Now we can solve for the slope m. We'll go ahead and subtract 2 from both sides. That will cancel this positive 2 and leave us with negative 1 minus 2 on the left, which will be negative 3, is equal to, we now just have m times a negative 2, or negative 2m. Then when we divide both sides by negative 2, we'll get m is equal to negative 3 divided by negative 2. Our negative signs will cancel with each other, and we'll get m is equal to 3/2. Now to write the line correctly in slope-intercept form, we always need to plug in for m and b, leaving x and y as they are. So we already know b is equal to 2, and we just found that m was equal to 3/2. So we plug those two things, and we can say here that in slope-intercept form, the equation of this line is y equals 3/2, our slope m, times x, and then b is equal to positive 2, so plus 2. And this is the equation of this line in slope-intercept form. Now the last format to talk about is standard form. Now standard form you can get by rewriting either point-slope form or slope-intercept form. So let's go ahead and get standard form using this equation here, y equals 3/2 x plus 2, which means we're going to get standard form of the equation for this particular line. So standard form is where we collect the x and the y term on the left side of the equation, and we leave the constant term on the right side of the equation. We also want to go ahead and get rid of fractions. So if we start with y is equal to 3/2 x plus 2, the first thing we want to do is multiply through everything by 2. So when we multiply through everything by 2, y times 2 is 2y. The 2 will cancel here with the 2 in the denominator, leaving us with just 3x, so 3x. And then 2 times 2 is 4. Now we just want to move the 3x to the left-hand side. So we subtract 3x from both sides, which will cancel it on the right, and leave us with negative 3x plus 2y is equal to 4. And this is standard form because we have our x and y terms on the right. That's the first thing we need. We always need to begin with the x term. So the x term needs to go first. We have the x term, then the y term. So that's second. And then third, we have to have the constant term, the term without the variable, over here by itself. And we have that as well. So this is standard form for the equation of this line. And it's important to know that you can write any line in any of these three forms, point-slope form, slope-intercept form, and standard form, and you can convert between them. So just like we did here, we started with slope-intercept form. We were able to convert this over to standard form. And if we wanted to, we could also convert either of these into the equivalent point-slope form. Now up to this point, we've talked about how to take a picture of the graph of the line and write the equation that represents that graph. We've looked at a couple of different lines, and we've written the equation of the line in point-slope form, in slope-intercept form, and in standard form. The way that we do that is by looking for pieces of information along the line, whether that's a coordinate point or two different coordinate points, whether that's the y-intercept, whether that's the slope, where we talk about the rise over the run to try to find the slope directly, or whether we find the slope from two different coordinate points. No matter what we have, we're looking for that kind of information so that we can plug into one of these formats, point slope, slope-intercept, or standard form, to find the equation of the line. But sometimes we're going to need to go the other way, where we have the equation of the line and we have to graph it. So here we've got the equation of three different lines, and we want to graph each one. Now, this first one, if we look at it, we should notice right away that this is in slope-intercept form. In other words, it's in the form y equals mx plus b. So if we see here y equals mx, this is m, which remember is our slope, and then we have plus b. Even though this is a negative sign, you can think about this as plus negative 2. Remember that minus 2 is the same as plus negative 2. So if we write it that way, then we can say that our y-intercept is negative 2. So with those two things in mind, we can go ahead and graph this line. We know that the y-intercept is -2, so we come here along the y-axis and we go down to the point where y is -2, right here. And then our slope is 3. Well, really we can think about 3 as 3 over 1, right? 3 is the same as 3 divided by 1. 3 divided by 1 is still equal to 3. So if this is 3 over 1, that means the change in y is +3 and the change in x is +1. This is rise over run. So this means go up 3 units, go over to the right 1 unit each time. So if I start with this point here and I go up 1, 2, 3 units, and then over 1 unit, then I can plot another point. Or if I go up 1, 2, 3 units again, and over 1 unit, I can plot another point. So this is the equation of our first line. Now for y minus 2 is equal to 2 times x minus 1, we should recognize this as point slope form. Remember that the formula is y minus y1 is equal to m times x minus x1. So I can pick out here that this value is m and that I have x1, y1 right here. So what that tells me is that I have a coordinate point x1, y1, 1, 2, so 1, 2, and I have a slope of m equals 2. So if I plot these things, first I'll find the coordinate point 1, 2, so 1 and 2, and then from there my slope is 2. Just like here we had 3, we could think about this as 2 over 1. So my rise over run, I go up 2 along the y-axis, over 1 along the x-axis. So up 2 over 1. Well, if I started this coordinate point, I could go up 2 over 1 this way and get to this point right here, or I could reverse both of those and go in the opposite direction, down 2 and to the left 1, and plot another point here, down 2 and to the left 1, and plot a point here. And then I'd have my line there. And then finally, we have our third line here, x plus 2y is equal to -1. The first thing we need to realize is that this is given in standard form. We have the x and y terms on the left together, starting with x and then y, and we have the constant term on the right. So this is standard form, and the easiest way to graph it is going to be to change it into either slope-intercept form or point-slope form. Let's go ahead and change it into slope-intercept form where we have y equals mx plus b. So to do that, we'll subtract x from both sides, and we'll be left with 2y is equal to -x minus 1, and then we'll divide both sides by 2, and we'll get y is equal to, remember we have like a -1 in front of this x, so when we divide by 2, we end up with a -1/2 in front of the x, and then here, -1 divided by 2 is -1/2. Now here, we have slope-intercept form, where the slope is -1/2. Remember, y equals mx plus b, where m is the slope, so m, the slope, is -1/2. And the y-intercept, again, we have to think of this as plus -1/2. So if we say plus here, and then -1/2 will be our y-intercept. So in order to find that, we'll first find the y-intercept, and we'll say -1/2 is right about here, and then our slope is -1/2. That means we're going to go down 1 along the y-axis for the -1, and then over +2 along the x-axis for the +2. So we'll go down -1 and over +2 and find another coordinate point. Down 1 and over +2 and find another point here. Or we could reverse both of those and go in the opposite direction. Go up 1 and over to the left 2, up 1 and over to the left 2. So that then is the graph of our third line. So really, we're just reversing the process that we went through before. We can either start with the line and find some combination of information about the slope or different points on the line, and then plug into one of the three formulas to find the equation of the line. Or we can start with any equation of the line, whether it's given in slope-intercept form, point-slope form, or standard form, and pick out pieces of information from that equation to then graph the line. Now, I do want to talk about one other special scenario, and that is how to deal with horizontal and vertical lines. So when you have a perfectly vertical line, the important thing to realize is that the slope of the line is undefined. So the slope m is undefined. Now that does not mean that m is 0. It means that m is undefined. And the reason is because remember that the formula for finding slope was m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Or you could think about it as change in y divided by change in x, or rise over run. The problem here with a vertical line is that x never changes. So no matter where I go along the line, I see that I'm always at x equals 2. If I'm right here, I'm at x equals 2. If I go up here, I'm at x equals 2. Or down here, I'm at x equals 2. So there's no change ever in x, which means the change in x, or x sub 2 minus x sub 1, it's always going to be 2 minus 2. It's always going to be 0. There's no change in x. So that means that the equation for the slope of the line is going to simplify to y sub 2 minus y sub 1 over 0. But remember, we can never divide by 0. We can never have a 0 value for the denominator of a fraction, which means that we simply can't define m at all. The slope m is totally undefined. So what then is the result in terms of how we write the equation of this line? Well, to write the equation of a line, all we need is one single piece of information. At what point does the line cross the x-axis? So if we look right here, where does that line cross the x-axis? Well, it crosses at x equals 2. Or really, you could look at any other point along the line, because here x is equal to 2, here x is equal to 2, here x is equal to 2. So you're starting to get the idea, and of course then we would just define the line as x equals 2. This is the equation of the vertical line. And if I instead had a perfectly vertical line passing through this point right here, then the equation of my vertical line would be x equals negative 3. Or a vertical line through here would be x equals negative 2. So it's always x is equal to whatever the value is constantly here along the line, or the point at which it crosses the x-axis. If you've been told that you have the equation of a line, and that the line never ever crosses the y-axis, or that the y-intercept, b, does not exist, then you know that the line has to be vertical. Because even if the line were tilted ever so slightly, either to the left or to the right, if it has any kind of slant at all, eventually it will cross the y-axis somewhere. Only a 100% perfectly vertical line will never cross the y-axis. So what then about horizontal lines? Well, for vertical lines, we said m is undefined. For horizontal lines, m is always equal to 0. And going back to our slope equation here, for m, that's because everywhere along this perfectly horizontal line, we always have the same value for y. So you'll notice that here, y is equal to 2, here y is equal to 2, this is y equals 2, we're at y equals 2 right here, which means that there will never be any change in y, because since y is always 2, we're going to get 2 minus 2, or 0. So we're always going to end up with 0 divided by x sub 2 minus x sub 1. And whenever you have 0 in the numerator, it makes the entire fraction 0. So the slope m will always be equal to 0. So if you're told that you have a horizontal line, you know right away that the slope is 0. Or if you're told that your slope is equal to 0, you know right away that you have a horizontal line. And in the same way that the equation of a vertical line was always going to be x equals some constant, whatever point it is where the line crosses the x-axis. For horizontal lines, the equation is always going to be y equals, and then a constant, the point at which the graph crosses the y-axis. So here we see that the line crosses the y-axis at y equals 2, this point right here. So the equation of this line is y equals 2, which makes sense because no matter where I go along the line, y is always equal to 2. So vertical lines are going to have the equation x equals some constant, and horizontal lines are going to have the equation y equals, and then some constant. I hope that video helped you, and if it did, hit that like button, make sure to subscribe, and I'll see you in the next video.